Hello everybody, this is Mrs. Pound, and I am back with another video from Chapter 2 about matter from BJU Chemistry's 5th edition. And what I'm doing today is I'm continuing on with Section 2.1, the classification of matter. So our objectives for today's video are to define pure substance and mixture, to organize matter into general categories on the basis of characteristics, and to interpret chemical formulas. So the first thing I want to talk about is that all matter can be divided into two general categories. They are pure substances and mixtures. A pure substance consists of only one type of matter. And so in the background here, I have sugar cubes. And sugar cubes contain just sucrose. So sugar cubes would be an example of a pure substance. Elements would also be examples of pure substances. We can also have mixtures. These are two or more substances physically combined into a variable ratio. And so you see a mixture of gourds in the background. And these gourds could be in any ratio we wanted. We could have, as we can see, just one pumpkin-like gourd here, or we could have 10 of them. And we could have different ratios. That it doesn't matter for the mixture. We could have any number of these and it would still be a mixture of gourds. We can have what's called a heterogeneous mixture, which is a mixture that has two or more distinct regions, which give it a non-uniform appearance, such as this mixture of gourds in the background. We can see different gourds. We do not see the same look throughout. We can see variations in them. This does not all look the same. In this mixture. There are various regions. We can pick the gourds apart and we could separate them out. However, we can also have what's called a homogeneous mixture, and this is a mixture that has only one phase, which gives it a uniform appearance. And another name for a homogeneous mixture is a solution. So an example is air. If we look at the air around us, it all looks the same. We know that it's a mixture of different gases like oxygen and nitrogen and carbon dioxide, but we cannot see those different gases to be able to pick them out. They're not clumped together so that we'd be able to separate them at all. The same thing with this Coke in the background. It all looks the same throughout, although Coke is a mixture of flavoring and corn syrup and carbon dioxide and color. It's all has a uniform appearance. We can't just pick out those different parts of it and say, aha, there's the color over there, or there's the flavoring over there. It's all uniform. It's one phase. Now, one classification for matter is an element. This is a pure substance that consists of only one kind of atom. And all of these elements are on our periodic table. So here is our periodic table, and each of these boxes represents a different element that is made up of only one kind of atom. So these are all of our elements. There are 92 naturally occurring elements. Above 92, those are all man-made. And these elements are what make up everything around us. Now, elements cannot be broken down into simpler substances by ordinary chemical means. This means that if I perform some kind of chemical reaction on the element, I cannot break it down into anything smaller. Now, atoms are made of smaller particles, but that is not using ordinary chemical means. I would have to use like a particle accelerator, and that's getting into nuclear chemistry, which is different. An atom is the smallest particle that makes up an element and is capable of chemical interactions. Now, one thing we should know is that if we go down to the very last atom, say of gold, that atom is not going to be gold colored. It's actually gold colored and has a lot of its properties because it's with other atoms of its same type. So you're not going to observe all of the properties of gold with just one atom, but it is the smallest particle that you can break that element down to and still have gold, still have the element. Now, all of our elements have a chemical symbol. This is a 1 or 2 letter symbol that identifies an element. So if we look back here on our periodic table, we see all of those symbols. And we can see here that most of them, like hydrogen up here, has 1 letter, H. Iron has 2 letters, Fe. Now, some of these down here do have 3 letters. They actually have names now, which do not show up on this periodic table. These have 3 letters because it's actually the Latin form of the number, and so they're abbreviating that. So that's why those actually have 3 letters. But most everything else has 1 or 2. And we can see like hydrogen is pretty easy because hydrogen H starts with the first letter of the name. But then something like iron, or my personal favorite is lead, Pb. Why are they way different? The reason lead is Pb is because its Latin name is plumbum. And so sometimes the symbols come from another language, and that's where they get that from. A lot of times too, we have a lot of elements that start with C, so we have to use 2 letters because we can't use a C for everything because C is carbon. So that's why a lot of them have 2 letters. Now, a further classification is monatomic elements, and monatomic elements are an element that occurs naturally as single atoms. And some monatomic elements are neon, argon, and xenon. Most things in the periodic table do not occur as single elements. These do because they are called the noble gases, and they do not like to form chemical bonds. So that's why they appear or occur in nature as single atoms. We also have diatomic elements. These are elements whose atoms naturally bond into 2 atom units, and the only elements that do that are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And this 2 behind their symbol tells us that they have 2 atoms bonded together for each molecule. Okay, for each molecule, they have 2 atoms bonded together, and we'll talk about what a molecule is here in a minute. Now, these are easy to remember because they occur in one spot mostly on the periodic table. So you're going to have to remember the oddball of hydrogen over here, but the rest of them occur over here, starting at 7, nitrogen. They form a 7 on the periodic table, and there are 7 of them in that 7. Okay, so what I want you to write in your notes is I want you to circle these, and I want you to write 7 at 7 next to where you circle. So 7 at 7 where you wrote these down to remind you that there are 7 of these making a 7 starting at 7. Okay, so that will help you. And then there's hydrogen over by itself over here. Hydrogen is kind of an oddball, so that's also why it's lifted up above the periodic table here on this periodic table. Now, there are also polyatomic elements. These are elements whose particles are normally composed of groups of more than 2 identical atoms. Sulfur does this. Sulfur is 8 sulfur atoms bonded together. That's why there is a subscript 8 after the S. And ozone is O3. There are 3 atoms of oxygen bonded together to make ozone. Now, we can also have molecules. A molecule is a distinct groups of atoms bonded together. They may consist of atoms from one element or from different elements. So, an example, a molecule of hydrogen is H2 because there are two hydrogen atoms bonded together. However, water is H2O because we have two hydrogen atoms bonded to an oxygen atom. So, one element, two elements. They are both examples of molecules. We also have compounds. This is a pure substance that consists of two or more elements chemically combined in a fixed ratio. And the example I have here is hydrogen peroxide, H2O2. So two hydrogen atoms are bonded to two oxygen atoms. Okay, and they are always in this fixed ratio. So if you have just H2O, that's water. That is a different compound. They have to have the same number after the element symbol here, okay, the chemical symbol, in order to be the same compound. We have a fixed ratio. And a compound is two or more elements. So H2 is not a compound, okay? Hydrogen gas is not a compound because it only contains one element. These can be broken down into simpler substances by ordinary chemical means. So, hydrogen peroxide, we can perform a chemical reaction on it and it can break down into hydrogen and oxygen gas. Now, those things we've been looking at, like H2O2, these are called chemical formulas. These are a combination of chemical symbols, coefficients, and subscripts that identifies the elements and number of atoms of each element in a compound. So, for example, when we look at H2O2, we can tell that there are two hydrogen atoms in it and two oxygen atoms. So this subscript here tells us the number of atoms. But we're going to get a little more complex here. If I see something like this, Ca for calcium, notice on our chemical symbols, the A is lowercase. So that tells us that this is one element. If it was capitalized, we would know that there were two different elements here. Now I have parentheses around HCO3. That's because this is a one unit. These are all bonded together as one unit. And then I have a 2 out here. What this 2 is telling me is that I have 2 units of HCO3. Okay, so what this does when I look at my atom count is Ca does not have anything behind it. So it's understood to be a 1. Just like in math, we don't write the ones, but they're understood to be there. So we know that we have one calcium atom. Now, for hydrogen, down here I say I have two hydrogen atoms. Well, where did I get that from? Well, I got that because there is understood to be a 1 after the H, but there's a 2 here out in the parentheses. So I multiply 1 times 2 to get 2 hydrogen atoms. So the same thing is true of the carbon. After carbon, there is understood to be a 1. We multiply it by the 2 outside of the parentheses to get 2 carbon atoms. And then the oxygen has a 3 after it. So we know that each unit of HCO3 has 3 oxygen atoms, but there's 2 units, so 3 times 2 is 6. So there are 6 oxygen atoms. We'll be practicing this more in class. So our objectives for this video were to define pure substances and mixtures, organize matter into general categories on the basis of characteristics, and to interpret chemical formulas. So don't forget your 5 questions, and I'll be back with another video.